first few steps. The first thing you need to do is go on to GeoGebra. Here it is. Place 3 points, which will be the vertices of a triangle, A, B, and C. This is the menu. If we click on it, it will start showing us things in the menu. You need to press onto the Tools button, Point. Now, we're going to put the points anywhere. Once we've done that, we are going to do the following. We are going to find the line, which is here. We click on A and then B, and it joins a line which goes on for an infinite amount of time. We need to press line again. We join B and C, and then we do the same for A to C. Next thing we need to do is work out the angles. Now, because I made this triangle in a counterclockwise manner, I put down A, then B, and then C, and then back to A. That's the opposite way the clock goes. You need to do the same motion when I'm doing the angles. If you do it the opposite way, you must do the angles the opposite way. I'll show you what I mean. Angle. So we want to find the angle between C, A and B. Because I placed the lines in this order, I am going to do the angle in this order. So you press C, then A, which is the one in the middle, and then the one on the outside. If this doesn't work, try it the opposite way around. B, A, C, and then it does the angle correctly for you. Let's do the next angle. C, B, A. There we go. Final angle. A, C, B. Perfect. That is the first few steps of your investigation. You must do a unique triangle to you. Do not copy anybody else. Now, what you need to do is then fill out this table. So I would copy this table and make a new document. On the new document, we need to do the following. We need to go to vertex A and we need to find sine of the angle at vertex A. Mine's going to be 56.3099. Work that out. We then need to go to B. Our angle is 45. We then need to find sine of 45. We then need to go to vertex C and find sine of 78.69. Now, this shows different vertices. Angle A, angle B, angle C. Now, with this topic we're going to go on to, we're going to be dealing with opposite sides. So the opposite side to angle A is going to be the side between B and C. The opposite side to angle at B is going to be the side from A to C. So what you have to do then is work out the length of the opposite side. There are multiple ways to do this. First of all, you could have a look on the menu here. And let's change the menu up a bit. Let's do a line instead of a segment. Or a segment instead of a line. Let's go from A to B. Go back onto the calculator menu. And it shows us here that A to B is 5 units long. So, the side opposite vertex C is going to be 5. Then let's do it again. We're going to go back onto here. We're going to press segment. We're going to go from this time A to C. We go into this menu and it says that A to C is 3.600. You could construct your triangle so it's nicer. I would recommend doing it to a few decimal places because the more you round, the more errors you're going to have. So A to C, which is opposite B, is going to be 3.6055. Finally, the next one we're going to have is the length from side B to C. So what we'll do is we'll get a segment and we'll type B to C, and then we'll go back onto the calculator mode, and it says it's 4.24. So we'd write this to a couple of decimal places, 4.24264. The last step you need to do then is the sine of the angle, so this answer divided by this one, and you'll write your observations. Let's just have a look at the last part of section A. You need to repeat the process for different triangles, so that's for one triangle. And it says use GeoGebra Classic to try and triangle with an extreme property. So you need to do it for something which has got a really long side or really large angle. And then we'll talk about that during the lesson or in video 2. Section B, all you have to do for this is think about H and then use trigonometry to think about how you'd write this in terms of other letters. So if we take this as an isolated triangle, what we would have is the following. We want to write H in terms of some of the other letters. Now the problem is we haven't got the whole of B, capital B, and we haven't got the whole of small case b. So what we must use is lowercase c and capital A. Can you write a trigonometric expression which says H equals something to do with C and A? Good luck with video 1.